Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Functions in Python, Part 1, for the Class 12 students of Computer Science. In this video, we are going to learn functions in Python, advantages, and built-in functions. So let's dive in and get started. When writing programs, we should avoid long, repetitive code. Functions help to keep our programs simple and short. So what is a function? A function is a small section of a program that performs a specific task that can be used repeatedly throughout a program, but the task is usually a calculation. Functions perform the task and return a value to the main program. Why do we use functions? Program code is easier to read and understand when it is broken up into smaller sections. Functions can make code shorter, simpler, and easier to write. Benefits of using functions. If something needs to be changed in a function, it only needs to be changed once, within the function code. This change will then appear wherever the function is used in the program. If functions weren't used, the code would have to be amended at every point that it appears in the program. Let's consider a real-life example of a dishwasher to understand how functions could be utilized in Python. Imagine you want to create a program that simulates the operation of a dishwasher. Now, look at the left side of the screen. This program is one long, complex sequence of statements. Now look at the right side. Here's how you could use functions to achieve this. In this program, the task is divided into smaller tasks. Each task is performed by a separate function. Step 1. Start the dishwasher. Define a function called start_dishwasher that turns on the dishwasher, fills it with water, and starts the cleaning cycle. This function can handle any necessary setup steps before starting the actual cleaning process. Step 2. Load the dishes. Create a function called load_dishes that takes a list of dishes as a parameter and loads them into the dishwasher. You can include checks to ensure the dishwasher isn't overloaded and handle any specific requirements for loading certain types of dishes. Step 3. Set the cleaning mode. Define a function called set_cleaning_mode that allows the user to select the cleaning mode for the dishwasher. This function can take parameters such as the cleaning intensity, temperature, and duration. It can also include validation checks to ensure valid input. Step 4. Run the cleaning cycle. Create a function called run_cleaning_cycle that performs the actual cleaning process. This function can control the flow of water, adjust temperature as per the cleaning mode, and run the cleaning cycle for the specified duration. Step 5. Unload the dishes. Define a function called unload_dishes that unloads the clean dishes from the dishwasher. This function can handle the process of removing the dishes, checking their cleanliness, and placing them in the appropriate storage areas. By breaking down the dishwasher operation into these functions, you can create a modular and reusable code structure. Each function is responsible for a specific task, making the code more organized and easier to maintain. You can call these functions in a specific sequence to simulate the complete dishwasher operation. Moreover, you can also add additional functions to handle error handling, user input validation, or even create a user interface to interact with the program. Python functions is a block of statements that return the specific task. The idea is to put some commonly or repeatedly done tasks together and make a function so that instead of writing the same code again and again for different inputs, we can do the function calls to reuse code contained in it over and over again. Functions are the most important building blocks for any application in Python and work on the divide and conquer approach. Advantages of using functions. Easy updation. Functions divide code into smaller, self-contained units. When you need to make an update, you can focus on the specific function related to the change, rather than navigating through a large, monolithic codebase. Code reusability. functions can be reused throughout the program or in different programs, saving time and effort by avoiding code repetition. Program handling becomes easier, only a small part of the program is dealt with at a time. Compact code. While working with functions, a common set of code is written only once and can be called from any part of the program, which reduces lines of code and programming overheads. Maintainability. Functions make code easier to maintain and debug by isolating specific tasks, allowing for targeted modifications and bug fixes. Readability. Functions improve code readability by encapsulating logic and providing clear and descriptive names for specific operations. Testing. Functions facilitate testing since they allow you to test smaller units of code independently, aiding in identifying and fixing issues. Functions in Python can be categorized into three types: built-in functions, modules, and user-defined functions. The built-in library provides a wide range of functionalities that can be readily used in Python programs without requiring any additional installations or imports. It includes modules and functions for tasks such as mathematical operations, file handling, string manipulation, data structures, networking, and more. In Python, built-in functions are predefined functions that are available as part of the Python programming language. These functions are included in the Python standard library and can be used directly without requiring any additional imports or installations. Built-in functions provide a wide range of functionality and are designed to perform common tasks or operations. We can discuss about these functions one by one. Type conversion functions in Python are built-in functions that allow you to convert values from one data type to another. These functions provide a convenient way to change the type of data in your programs. Here are some commonly used type conversion functions. Int function converts a value to an integer. Let's look at some examples. Look at the Python code. Line 1. Converts the float arguments 3.14 to integer 3. Line 2. Converts the string arguments 112 to integer 112. Line 3. Int function can convert the floating point values to integers, but it doesn't round off. It chops off the fraction part. So minus 32.4 becomes minus 32. Line 4. If no argument is passed, int function returns 0. Line 5. Generates an error if the argument is a string value. Str function converts a value to a string. For example, str of 42 would return the string 42. Float function converts a value to a floating point number. Let's see some examples. Look at the Python code. Line 1. It converts the integer arguments 314 to float value 314.0. Line 2. Converts the string arguments to float. Line 3. Addition of integer values results in float value. Line 4. If the argument is an expression, the expression is evaluated and float function returns float value. Line 5. Converts a string value to float value. Line 6. If no argument is passed, float function returns 0.0. In line 7. If the string argument contains any character other than leading plus or minus sign and floating point number in the current format, then float function results in an error. The input function in Python is used to interact with the user by accepting input from them. It allows you to prompt the user with a message or a question and waits for the user to enter a response. The response entered by the user is then returned as a string. Prompt is an optional parameter that represents the message or question you want to display to the user. It is used as a prompt to inform the user about what kind of input is expected. If no prompt is provided, the function will simply wait for the user to enter input without displaying any message. The input function reads the user's input as a string. Look at this example. Here the input function prompts the user to enter their name, and the entered name is stored in the name variable, and the program displays a greeting message with the entered name as hello followed by their name with exclamatory point. If you want to perform numerical operations on the input, you need to convert it to the appropriate data type using functions like int or float. Now, look at the example. The input function prompts the user to enter their age, and the entered age is stored as a string in the age variable. Since we want to perform arithmetic operations on the age, we use the int function to convert it to an integer. Finally, the program calculates the age of the user in the next year. The input function can be used without any arguments. In that case, it simply waits for the user to enter input without displaying any message or prompt. Now, look at this example. When the program executes the input function without any arguments, it waits for the user to input something. You can see the cursor waiting for the user to input something. Once the user enters a value welcome to Sally in bytes and presses the enter key, the entered value is stored in the value variable. The program then proceeds to print the entered value using the print function. Using input without any arguments can be useful when you want to give the user a chance to provide input without providing any specific instructions or prompts. The eval function in Python is a built-in function that evaluates a string containing a Python expression or statement. It allows you to dynamically execute code that is represented as a string, enclosed in quotation marks. If the given argument is not a string, or if it cannot be evaluated as a number, then eval function results in an error. Look at these examples. In line 1, the eval function takes the string 30 plus 45 foot as the valid mathematical expression to be evaluated, that adds the numbers 30 and 45 together and returns the result, 75, on the console. In line 2, the eval function takes the string 30.5 plus 45 foot as the mathematical expression to be evaluated, that adds the floating point number 30.5 and the integer 45 together and returns the result, 75.5 on the console. In line 3, since the expression is not provided as a string, it results in type error. Illustrating eval using input function. The eval function evaluates the string like a Python expression and returns the result as an integer. Now, look at this example. In this code, the eval function is used to evaluate the user's input as a Python expression. The expression is obtained using input function, and then eval function evaluates it. The evaluated result is stored in the eval variable, which is printed using print function. Finally, the type of the evaluated value is printed. It's an integer. The max function returns the largest item in the provided arguments. The min function returns the smallest item in the provided arguments. In case of string-type argument, ASCII values of characters are compared for retrieving highest to lowest values using max and min functions. Now, look at the examples. In line 1, the max function is called with the arguments 45, 25, 33, and 83. The max function compares the values and returns the largest value among them, which is 83, and is printed. In line 2, the min function is called with the arguments 45, 25, 33, and 83. The min function compares the values and returns the smallest value among them, which is 25, and is printed. In line 3, the max function compares the strings using ASCII values and returns the largest string among them, which is Singapore. The ASCII value of uppercase S is 83. In line 4, the min function compares the strings using ASCII values and returns the smallest string among them, which is Delhi. The ASCII value of the uppercase letter D is 68. The abs function in Python is used to return the absolute value of a single number. It takes an integer or float number as argument and always returns a positive value. It returns a floating or integer number depending upon an argument. Syntax is abs of number. The number parameter can be any numeric value, such as an integer or a floating point number. Let's see some examples. In all these examples, the abs function is used to calculate the absolute value of the given numbers. The function returns the positive magnitude of the number, regardless of its original sign. The type function in Python is used to determine the data type of a variable or an object. It returns the class or type of the object that is passed as an argument. Syntax is type of object. The object parameter can be any value or variable whose type you want to determine. In each of these examples, the type function is used to determine the type of the given object. The function returns a class object that represents the type of the object. The Boolean argument given to type function should have T capital letter for true and F capital letter for false, otherwise it will generate an error. The len function in Python is used to determine the length or the number of elements in a sequence or collection such as a string, list, tuple, or dictionary. Syntax is len of sequence. The sequence parameter can be any sequence or collection for which you want to find the length. Let's see some examples. In each of these examples, the len function is used to determine the length of the given sequence. The function returns an integer value representing the number of elements in the sequence. The round function in Python is used to round a given number to a specified number of decimal places or to the nearest whole number. Syntax is round of number, n digits. The number parameter is the value that you want to round. The n digits parameter, optional, specifies the number of decimal places to which you want to round. Let's see some examples. When n digits is not specified. Look at line 4. This call rounds the number 3.14159 to the nearest whole number, which is 3. In line 5, the number 3.64159 is rounded to the nearest whole number, which is 4. When n digits is 0. In line 8, the number 3.14159 is rounded to 0 decimal places. Since n digits is 0, the result is a whole number represented as a float, 3.0. In line 9, the number 3.64159 is rounded to 0 decimal places, resulting in 4.0. When n digits is positive integer. In line 12, in this case, the number 3.4559 is rounded to 1 decimal place. The rounding rule dictates rounding to the nearest even number, so the result is 3.5. In line 13, the number 3.532 is rounded to 2 decimal places, resulting in 3.53. In line 16, when n digits is negative, rounding is performed on the left side of the decimal point. In this example, 1234.56 is rounded to the nearest tenth, tens place, because -1 is passed as digits. The result is 1230.0. In line 17, 1258.42 is rounded to the nearest hundred, hundreds place, since -2 is provided as n digits. The result is 1300.0. The range function in Python is used to generate a sequence of numbers. It creates an iterable object that represents a sequence of numbers from a starting value to an ending value, with an optional step size. Syntax is range of start, stop, step. The start parameter is the starting value of the sequence, inclusive, which is optional. If not provided, it defaults to 0. The stop parameter is the ending value of the sequence, exclusive. The sequence will include numbers up to, but not including, this value. The step parameter is the increment or step size between each number in the sequence. It is optional and defaults to 1 if not provided. Let's see some examples. In the first example, range of 5 generates a sequence of numbers from 0 to 4. In the second example, range of 1, 6 generates a sequence of numbers from 1 to 5. In the third example, range of 2, 10, 2 generates a sequence of even numbers from 2 to 8, incrementing by 2. In each example, invoking the list, we will see the sequence of numbers. Thanks for watching. Watch the upcoming videos. Functions in Python Part 2. Modules, user-defined functions. You can check the link in the description box below.